Hello everybody. Today we are going to take a look at Leetcode question 3066, minimum operations to exceed threshold value 2. We are given a zero-indexed integer array nums and an integer k. In one operation, we can take out two of the smallest number in nums, remove them from nums, and add minimum of those two numbers times 2 plus maximum of the two numbers anywhere in the array. We can only do this if the length of nums is greater than or equal to 2. We have to return the minimum number of operations needed so that all the elements in the array are greater than or equal to k. Fine. Let's take a look at the examples. 2, 11, 10, 1, 3, and k is equal to 10. Right. So since there are numbers less than k, we can perform the operation. So we take out two of the smallest numbers, that's 1 and 2, and we remove them. So the array now becomes 11, 10, and 3. And what we have to do now is we have to calculate the minimum multiplied by 2 and then add the maximum number to it. So minimum is 1 times 2 plus maximum is 2. So this will be 4. Right? 2 plus 2 is 4. So we add 4 to the array. Great. Now we again perform the operation again because there are numbers less than k. 3 and 4 are less than 10. So we again perform the same operation. So we remove these from the array. So the array now becomes 11 and 10. And the value that we have to push to the array will be 2 times minimum of 4 and 3, that is 3, plus the maximum number. So 2 times 3 is 6, plus 4, that is 10. So now we can push 10 back into the array. And now if we see, all the elements in the array are greater than or equal to k now. So we stop here. So we did two operations. So the result will be 2 is what we have to return. Right. Okay. Thinking of the solution, the most brute force approach would be to just scan the array, find the smallest and the second smallest element in O of n time, right? Pop them, keep the track of the indexes, pop them, and after popping them, we append the calculated new value. That is one solution, but for this we'll have to scan the array n times. Yeah, the worst case would be we have to scan the array n times, so it would be an n square solution. Right. One more observation we can do here is we do not need to keep track of the indexes. Right, indexes are not required, so we can sort the array or use a data structure that can keep the array in a sorted order for us. So since we only need the smallest and the second smallest, we can make use of a heap. So in a heap, as we know, we can keep elements in a sorted order, whether increasing or decreasing. So in our case, we can use a min heap, right? A min heap to keep numbers in the sorted order. So when we push the elements into the heap, it will keep the minimum values at the top, so we can pop them out, and anything that is greater will be after these numbers. So we'll come to know if any number is less than k by looking at the top of the stack. If a number is greater than or equal to k, it means all the numbers after that will be greater than or equal to k, right? So we can make use of a heap. We can push the numbers so it will be kept in a sorted order like 1, 2, 3, 11, 10, and 11. So we take out the top two numbers, we calculate, and we already know the result will be 4. So once we push 4, it will be 4, 3, 10, 11. Because it is a heap, it will auto shift up or shift down. and the heap will become 3, 4, 10, 11. Again, we can perform the same operation because the top is less than k. So again, we take the top two elements, and that will be 10 because we have calculated 10, 11. And now, after shifting all the values up and down, this is what the final heap will look like. And we can infer from this that since number the top of this um, heap is 10, all the numbers after that will only be greater than this. So we can stop at this stage. Great. Thinking of the time complexity. So to first heapify the to heapify the array, we'll take O of n time, right? And then to pop the elements from the top and then push the elements, we'll take log n time. And we can perform the operation at most n times. So this is what the time complexity will look like, n times log n. Let's write solution for this. So we'll create another array just so that we do not interfere, we do not change the input array. And after we have made a copy of this input, we'll just heapify this. So this operation will take O of n time and it will heapify the input array. It will convert the given array to a heap. And then we have to perform the operation while the top of the heap less than k. We need to keep the track of the count or number of operations. So we'll create a variable called count to keep track of the count. And after everything is done, we have to return this count. And we can perform the operation only when there are at least two elements. And if we look at the constraints, it says input is generated such that the answer always exists. So we can omit the check of checking if the queue length is greater than or equal to 2. This should also be fine. Great. So we take out the top two smallest numbers from the heap by using heap pop. And then we push back this. We increment the count. Right. So we create a copy of the heap. We heapify the new heap. Um, we create a variable called count, and while the top of the queue is less than k, we perform the operation. We pop the elements, we push the new element, and we increment count. Let's run it. Looks good. Let's submit. Great. Thank you.